Welcome to the future. So I'm at the end of the 45-week test of the Epaper watch, and how did it go? Well, I'm at the end of the test, but it's not 45 weeks, it's more like 2 days. So it didn't go too well. So I ran it and everything was fine, set it up with a new battery, lovely. Then next day I came in and I accidentally reset the supply somehow and lost the time, so I thought that was a bit odd, but anyway. Next day I came, measured it, I actually pressed the button to read the time, and it just stuck. It stuck on a blank screen after the first part of the update where it flashes black. Not too happy at that point. So the 45-week test lasted 2 days, and I think what the problem is when I was setting up the clock on the STM32, what I did was leave it running at 36, 48 or 72 megahertz, I'm not sure, I think it may be 72 megahertz, which is the full sort of 30 milliamps, until I got into the setup loop when I changed the clock speed down to whatever I was going to run with, which was about 8 megahertz at the time. And I think the 30 milliamp load was just destroying the battery, even in the short startup time. So what I've done is I've taken the clock initialization routine from the variant.cpp file in the Arduino IDE, and I've got a copy of that. You can override it. I've got a copy of it now in the sketch. So originally I was changing the clock speed from the very beginning, from reset, by changing the variant.cpp file, because I couldn't get the clock speed setup function to actually compile. Now for some reason that's just gone away, that problem, and it now does compile, so I don't really know what the difference was. So now that means I can have a sketch with whatever clock speed I want without changing the IDE files, which I didn't really want to do because I might forget to change them back and end up running everything that I do from now on at 8 megahertz. So I've done that, and now the code starts up and it runs at a lower clock speed. I think I'm down to around about 1 megahertz now. I'm not absolutely certain about the clock rates. I'm going to have to confirm all that. There's quite a lot of working through register settings and things to work out exactly what you're running at and where, because all the peripherals have their own dividers and things. So it does mean that the serial output isn't going to work because there's a factor of 0.5 in the dividers, which means you can't actually find a baud rate that works. So at the moment I've got that disabled anyway to try and save some power. So this code now starts up at a very low clock rate, runs, and does everything it's supposed to do. I've adjusted the delays. I've adjusted the delays to take account of the slow clock rate, which means that all the buttons and everything work. So now I'm taking a reading once a day, and I've just taken one, so it's 8 minutes to 7 in the morning, and measuring the battery as we go. So I'd measure the battery before and after I take the reading. So at the moment we're what are we running at? Let's hope I don't reset it. 3.167 volts. So let's actually measure that. 3.167 volts. So at the moment it's running about 3 milliamps or so when it's up and doing its stuff, and in sleep it's still the 3 microamps, although I did measure it on this meter, which is a more expensive, better meter than the one I measured it on originally when I measured it at 3 microamps, and this actually measures it at 2 microamps, so that's good. So yeah, I'm now going to start another 45-week trial which hopefully will last more than 2 days. It's looking a bit better at the moment, the battery hasn't collapsed. So I think putting a heavy load, 30 milliamps, 20 milliamps even 10 is actually quite a high load for these batteries. Putting a heavy load like that seemed to have basically knackered the battery, and the voltage dropped down to such a level that I couldn't get the thing to actually run from that battery, and that's only after a couple of days and about 3 readings. So I'm hoping this will last better, because 3 milliamps, even though it's still quite a high current, is sort of more within the acceptable operating range of this type of battery. So we'll see how it goes. So obviously running at 1 megahertz instead of 8, everything is slowed down, but it doesn't make too much difference. It takes so long to update the display anyway that changing from 4 seconds to get a display to 8, I'm not really too bothered. I've also made another change, so to try and get the current down while we're operating, what I've done, there's an idle check which checks the Epaper idle signal, and the original code sat in a loop. I tried to put the processor into sleep mode, but that didn't go too well. So what I do now is when we enter that loop, I change the clock rate and I divide by 512, not 256. I divide by 512, which must take it down to a few hundred kilohertz, and sit in the loop at that reduced clock rate, and that will reduce the current. So instead of sitting in a while loop burning current, it drops right down while it's in that loop. And I had to check, and even at 1 megahertz you still got thousands of loops we were going around there, so dropping it down does make a difference. So it's a fast processor compared to the display. So I think that's probably dropped the current consumption down considerably during those idle loops. Not as good as sleep or shutdown mode, but shutdown mode would reset the processor, and that's not going to work. Sleep mode, I don't think it actually reduces too much, so I think it's probably comparable. So that's a little addition and a change to the code. So hopefully this will run for, well, hopefully it'll run longer than 2 days, but I'm hoping it will run considerably longer than 2 days, and we'll get at least a few months out of it. But we've just got to see, really. So the next update will also be from the future,